Right, so in this module we're going to be looking at a final form, or yet another form of conditional execution called the switch statement. And the switch statement lets us do actually nothing that we can do with a switch statement we cannot do with an if statement. The if statements are actually far more versatile than switch statements, but there are a specific class of types of programs or a specific class of logic that lends itself very well for switch statements. So let's go forward with this. This is going to be covered in section 3.3 in the text. And to demonstrate a little bit of the problem, we're going to start by working on a specific type of problem called a menu-based program or a menu-based interface. So menu-based programs are obviously very common. Lots of times we'll present the user with a series of options. The user might press 1, 2, or 3 to tell the program what kind of action they want to take. In that case, we might read in integers. Or better yet, lots of times we'll present a menu that allows the user to type in a letter. Maybe it's a yes or no, y or n. Maybe if we're going to present shapes, maybe it's going to be the first letter of each shape, and that's what we'll start out with this. So we would construct, using the stuff that we already know, we'd construct a set of if and else statements to see whether or not their choice that they type in equals some of our selections that we're going to support. So let's start to build one of these menu-based interfaces using standard if statements. So what I'm going to do is I'm going to write a program that asks the user if they want to compute the area of a rectangle, a square, or a circle. And for a rectangle, of course, I'd ask for the right dimensions, square the same thing, and circle I'd ask for a radius. So really this is going to be kind of like 3 mini programs based on their menu selection. So let's start this up. I'm not going to do any of the calculations first. I just want to get the menu itself to work correctly. So I'll have choice. That's just going to be a character, so they're going to press R, S, or C for their choice of shapes. I'll print out a prompt. So let's just first say this is an area calculator. I'll press or I'll tell them what they can enter for their different options. Okay, so there are 3 different prompts. I'll read in their choice, so I'll say enter your choice. And let's just construct a series of if-else statements and print out the shape that the user typed out or typed in first. So we'll say if choice is equal to C, let's just print out circle. Else if choice is equal to R, see out rectangle, and else. And we could do else, assume that the choice is a square. Now the problem with using the else statement here is else catches all, right? So if it's not C and it's not R, then we're going to assume it must be a square. And hopefully we recognize that our users don't always follow the directions, right? So if we ask them to type in C, R, or S, they might just quickly hit the keyboard. They might hit A right next. The letter A is right next to S, and that would be a mistake. Or they could enter in some crazy letter, whatever letter they might type in, and we would interpret that as a square. So it's probably better to actually check specifically for S. and we'll just type that out first. And then have the else condition as sort of a fourth option where the user entered an invalid choice. So let's build this and make sure we've got the correct output. Okay, so we've got our calculator. I type in C, we get circle. Type in R, we get rectangle. Type in S, we get square. Type in W, and we get an invalid choice. All right, so that's good. Now from here, each one of those if clauses are really just their own program. And I'm going to start with sort of kind of a naive approach and really duplicate a lot. I'm just going to say double radius, cout, please enter radius, cin, radius from the user. I'm going to say double area equals 3.151414159 times radius times radius, and print out the area is area. Okay, so there's my first menu selection. Go ahead and run it. And now when a user types in circle, we'll actually have a real program. Next is rectangle. And again, I'm going to treat it just as its own little mini program. Width, height, cout, please enter width. Cout, please enter height. And double area equals height times width. And cout area is now remember that these two area variables, they are technically completely separate and independent variables because the scope of a variable is limited to whatever braces it's been declared in. So down here, this is a different area than was over here, and as we'll see later on, we won't be able to use these areas anywhere else in the program. For square, it's almost the same as rectangle, so I'm just going to copy and paste most of it. We just want the width, though. And there we go. So we'll build it. Now I can type in rectangle, get 20. Type in S for square, get 9. And we've got a functioning program. Now, if we look at this, let me make this a little smaller so we can see more of the screen. There is a lot of duplication in this code. And the first primary part that I see is these print statements. I'm repeating the same exact statement in each one of these clauses. And it's the last thing that happens. So what I'm going to do is I'm going to move this out of the if clauses. We always like to take anything that's common to the else ifs and move it out, maybe above, maybe below. But we get a compiler error, right? We get an immediate compiler error and it says area is undefined. And it's important to note exactly why that is. These areas that we've defined in these braces, in these else clauses, none of them are actually visible out here because they're all declared inside their own clause. Now, the absolute worst thing to do is to just blindly sort of declare something, right? And celebrate because your syntax error went away. That's a recipe for disaster. You always want to be very, very clear as to what's causing the problem. Is it just a syntax error, or is it really just a flaw in your logic? And if I build this, Visual Studio is actually not even letting me permit this. It's saying, well, wait a second, you didn't even initialize area. And that might be confusing because, look, you've got area, but remember these are different variables. Again, worst thing you could do is just initialize it to make the compiler error to go away. That doesn't make any sense. And in fact, now if we run the program, I will have a circle, a radius 5, and the area comes back as 0. Rectangle 4 and 5, and the area comes back as 0. And it's because this area variable up here is never actually being used. Each time we make our way into the if statement, we are redeclaring an area variable. Within the context of this if statement, and the only things that are really using or are dealing with areas is this assignment, this area no longer exists. This area is invisible. It's hidden by this other variable that's been declared at the closer scope. So we never want to keep declaring these variables over and over again. It gets very confusing. Inside these if statements, we're talking about the local area that's been defined inside the if statements. Out here, the only area that we're talking about is this. And Visual Studio makes this pretty easy to see, by highlighting, right? So when you double click this area, it shows us which one we're talking about. Now the solution to this is to not declare new variables inside these if clauses. Just reuse the same area. And you might be looking at this and saying, well, wait a second, area can't be pi r squared and also be height times width, but recognize that we're only going to enter in to one of these clauses in our program. These are all mutually exclusive. I saw a warning here for height. I'm going to take that out too. So if I take the declaration and I just use the variable itself, now I'm using the same variable all over the place. I'll have a better result. Then I'm back with my correct answers. Now there is one problem with this. If I type in W, invalid choice, the area is 0. Now invalid choice is okay. I wanted that to print out, but I don't want area is 0 to print out. That doesn't seem to make much sense. If it was an invalid area or if it's an invalid choice, I shouldn't print that data out. But if we look at the way the code works, I've got an if, an else if, an else if, an else, and then afterwards I print this out. Right? Well, that's easy to fix. When we have an invalid choice, we don't want to continue. Right? We don't want to keep going. By the way, the correct solution is not to look at this and say, well, if area is 0, don't print this out. You don't want to do something like this. Because if area is not equal to 0, that's not really getting at the heart of this. You don't want to print this out because there was an invalid choice made. It's not because area is 0. Area could have been 0 because the user typed in 0 for height and width. Right? So it's not about whether area is 0. Area is 0 because we initialized it to 0. What we want to do is we want to avoid even reaching this line of code. And what we could do is just say return 0. Return 0 out of main returns control back to the operating system. It shuts down our program. In this case, once we hit that invalid choice, we will stop and we won't continue. Then we can see invalid choice come up. Beyond that, there's probably not a lot more optimization of this code that we can do. We are declaring 2 width variables. That's probably not that big of a deal in this circumstance. I would normally probably avoid declaring variables in if statements if this is any larger of a program, but it's sufficient. It's okay for what we're doing at this point. One last usability thing about a menu. If I run the program and I type in uppercase R, notice my program comes back and says invalid choice, and that doesn't really reflect well on our programming skills. If a user runs a program and they're asked to type in R, most users are going to expect that a capital R will still be a rectangle, and so we'd like to make our program a little smarter than that. So if we were to try to accept either lowercase or uppercase c for circle, we certainly don't want to do something like this. Right? That would be a really bad example of duplicating logic. Right? if it's uppercase C and or it's lowercase c or uppercase c, we're doing basically the same exact thing. That's definitely a bad idea. That's where we want to use our logical operators from the last module. Right? So we're going to say or choice equals C. Notice that the left and right side of the or operator are completely independent and full-fledged Boolean expressions. Do not write something like this. Don't say is choice equals lowercase c or uppercase c. In this context, this will evaluate to true or false based on what c is. This evaluates to true, and then your whole thing will be something or true. Even though when you say it out loud, this kind of makes sense, you always have to have a full-fledged Boolean expression, something that truly evaluates true or false on each side. And we can do this on all of our menu choices to support our lowercase variants. All right, so this is your kind of your standard typical menu-based selection program, and for menu-based programs there are other constructs. There's another construct called a switch statement that I wouldn't say that necessarily works better, but it's another option, and so it's a matter of personal choice really which one you want to use. But a switch statement, let's flip over to the syntax. A switch statement sets up a little bit of a smaller, less syntax, less wordy way of comparing an expression against a series of constants. Before we actually get into the details of case and all this kind of in default and what that actually means, let's think about what a switch statement is actually. What kind of situation would warrant a switch statement? So in this slide, we're going to see the criteria for where we'd use this switch statement. One is we are always comparing the same expression against a series of choices. So flipping back to the code, notice that the expression that we're comparing against choices is always the same thing. It's always choice. It's always a variable. Now that could have been an expression. That could have been x plus y. But it has to be, if you've got a series of if statements that are always using the same expression against a series of choices, a switch may be something that's applicable. If you've got if statements that are, in one branch of the if statement comparing x to 5, and in another branch of the if-else if statement comparing y to 6, or y to the letter C and x to the letter A, that won't work. It's always the same expression being compared against something else. Second, we're always comparing with equality. Right? Again, going back to this code, you'll notice that exhibits this as well. Right? We always have this equality statement to check. It's not less than, it's not greater than. Third, your choices are integer-based. The values that you're comparing this expression with, if they're integers, if they're shorts, if they're longs. Characters, remember, are just ASCII codes, so those are integers. What this is specifically excluding is that we cannot write a switch statement if our choices are doubles, or floats, or something like that. And then finally, if our choices are mutually exclusive. And this is a little bit fuzzy in that, if we look at this, they're not quite mutually exclusive. C and uppercase C do the same thing. But what we're really thinking about is, given a specific choice, you will only fall into one of these categories. Right? That's what we really mean by the choices are mutually exclusive. Given a specific value, maybe S, we're not going to actually execute multiple parts of this clause. So given that criteria, stepping back to the syntax now, we can put the expression that's appearing in our if statement over and over again all the way up top in this switch clause, followed by these braces, and then each thing that we're comparing the expression against represents a case. So we would have case the letter A, case the letter B, or case the letter S for square, case the letter R for rectangle. We'll follow that with all of our statements, or colon in all of our statements. followed by a break. And a break statement at the end of our case is very, very crucial. That's what tells C++ not to continue to execute the rest of the cases. It's analogous to the closed brace in an if or an else statement. At the very end, we can have a case called default, which would execute if none of the cases above were actually used. As we go through a switch statement, when we pick a case that actually works, we're going to fall out of the switch statement after hitting that break. Right? So we won't execute multiple case statements that way. So characters are fine. Those are integer constants. Variables are not. Variables are okay in our integer expression up here, but variables are not okay here. Expressions not okay. 4.5 is a double, not okay. So if we look at an example, let's say I have a set of if statements that says if x equals 5 or 6 or 7 or something else. Right, this is kind of a classic example of something that can easily be turned into a switch statement and maybe save you a little code. Right, so notice that x is what's being compared against my choices each time. So that's that integer expression. That goes up here, switch x. Open and close brace. And now I've got my choices, 5, 6, 7, and everything else. Case 5, case 6, case 7, everything else, my break statement. What I do within these cases is kind of trivial in this slide. C adding 1, C adding 2, C adding 3. I've got my print statements in the corresponding cases, and notice the break statement here. If I leave these out, if I left this break statement out here, for instance, and the user typed in 5 and x was equal to 5, I'm going to enter in this switch. Case 5 is going to be my first match. I'm going to print out 1, but without this break statement, I'll continue through it. I'll continue executing. I'll print out 2 then. And if I never hit a break statement at all, I'll go right through all the way to default. So if I leave out all the break statements, it'll literally say 1, 2, 3, the rest. So the break statements are very critical here. We'll see in a moment why they exist and why you might want to omit them occasionally. So let's take the menu, if we look back at the criteria over here, if we read through this carefully and you think about a menu-based program, it's essentially this. This is what a menu-based program is. So let's take our menu-based program of shapes and convert that into using a switch statement. So my switch statement will start off by switching on that choice variable. And I'm going to leave out the uppercase versions right now. I'm just going to have case C, break, and I'll fill in the code in a minute. Case R, break. And it's a good idea to write that break statement right away before you even fill in the rest of the code, because it's easy to forget later on. Default is optional. In our case, we had an else clause, so we're also going to have a default clause. And now I can bring in our code. So for a circle, we're going to calculate a radius and then keep going, breaking after we calculate the area. For a rectangle, and for a square. And then finally for an invalid choice in the default section. So they're very equivalent. And whether you like the if statements or the switch statements is really a matter of personal preference. You need to know how they both work, but there's never a situation where you must use a switch statement. But this is a good example of where it's pretty nice, pretty applicable. If we compile this, we will get an error, and the issue is that width is being redeclared. Now, we didn't have that problem before, and the reason we didn't have it is that each clause in an if statement had one of those curly braces. In a switch statement, notice the cases are not delineated by these braces, meaning everything in a switch statement is all within the same scope, so these are variable redeclarations. I mentioned that normally I tend not to declare variables right in an if block. In a switch statement, you definitely don't want to do that. It'll lead to a lot of issues. So I'm going to move them out. I obviously don't need to redeclare. I don't need to declare 2 widths for the same reason I don't need to declare 3 areas. Okay. So we've got our program. It'll work exactly the same as it did before. Rectangle, 20, 40, square, circle, and if we type in W, invalid choice. So now the next question is, well, how do we get our uppercase values? So there's a reason why the language of C++ forces you to write break to prevent you to moving from case to case. And the reason is if you leave it out, sometimes that actually can be beneficial. So to support multiple choices, we can't do, by the way, something like this. Right? We can't put uppercase values in by using an OR like that. The expressions don't work for switch statements. But what we can do is we can add an extra case. Case uppercase C. And notice I don't have anything here. I can write a C out statement, let's say, let's prove it to ourselves. So capitalized. But I'm leaving out the break statement. Specifically, that's what's important. If the user types in an uppercase C, let's build this and see what happens. If the user types in an uppercase C, I can see capitalized, but then I see please enter radius. The absence of the break statement causes this case to execute and then fall right through to the very next case. And it just so happens, because I arranged this smartly, that next case happens to be the lowercase c, which contains the logic for a circle. This would not be a good thing to have down here, for instance, because it would fall into a rectangle, and that's not what we want. Now, we don't really even need that C out statement. Right? So we can just say case C and do nothing, just fall right through. And I'm going to do that for R and for circle as well. I don't need to do anything like that for default. And now I'm supporting capitalized versions as well. And this is probably the quintessential reason why we have fall through in case. Unfortunately, if you program enough with switches, you'll find that the leaving the break statement out happens enough that it can almost be viewed as sort of a language flaw. You leave it out, and then you have this weird case fall through. It was accidental, and it's a source of some bugs. It makes sense in the context of this not to have it, but there are actually very few other situations where it makes sense not to have the break statement. So other languages, so Java in particular, will make it illegal. They have a switch that Java has a switch statement that looks almost identical to C++'s, but it's illegal not to have a break. It's actually a syntax error not to have a break statement in one of your clauses if your clause has any code. It's okay to do something like this because you don't have any code at all. In C++, this is perfectly legal to leave the break out. And just so we see, I've been talking about how it could be a bad error. Let's prove it here. Let's close this program. It can certainly lead to some problems. If I type in rectangle, everything looks perfectly fine. But if I type in circle, I enter the radius of 5 right here. I calculate area, but then I'm falling right through. Right? Because I left that break statement out, now I'm asked to enter in a width. And the area is, of course, just whatever that ended up being. So the absence of the break when it's supposed to be there leads to a lot of bugs. But notice sometimes we don't put it there if we're trying to capture sort of multiple options. And that's probably the biggest pitfall when using a switch statement. We need to be extremely careful not to omit the break when it should be there, and remember that sometimes not putting it there makes some sense. The other thing that we need to remember, and this will be kind of harder to do without knowing it, the compiler is going to catch you here, You cannot compare two variables with a switch. So you can't have some cases matching against X and another case matching against whatever's stored in Y. No, that doesn't work. We can also only compare against integers. Good rule of thumb here is if you've got a menu-based program, if you've got a clear, if we go back to the slide that says the criteria, if you've clearly met all of these conditions, it might very well be easy to use a switch statement. If you don't meet these conditions, or if you're walking through this and you're having a real difficult time forcing the problem into a switch statement, try writing it as an if statement first. The if statement is more flexible. It might be a little bit more work. It might be able to be changed later into a switch statement. But if you're having trouble making something into a switch, don't force it. It might be that it's just easier to write with an if statement. So over time, you'll get some judgment on that.